The stimulus received from external factors like heat, pressure, odor, movement, and current generates impulse which travels rapidly along the length of a neuron. This transmission of impulse is not a simple electric current, but it is an electrochemical change propagating through the length of an axon. This is how the neuron communicates the stimulus to another neuron or effector organ. Consider a situation where an isolated neuron from aplysia, sea slug, having a long axon is placed under experimental conditions. Two electrodes, 1 and 2, are placed several centimeters apart on the surface of an axon. They are connected to the recording equipment. During an experiment, an extremely small electrical stimulus of P unit was applied to the cell body. It did not create any response as is shown in the figure below. When the intensity of the stimulus gradually was increased up to a certain level, that is your Y unit, then a response was recorded. So when the electric impulse is of the P unit, there is no recording, then there is no stimulus. But when it was increased up to the Y unit, response was recorded. So this entire question is nothing but it is based on the concept of action potential. Let's see what is action potential. Action potential. Action potential, it is a sequential change in the membrane potential due to opening and closure of various ion channels and its propagation along the excitable tissue in undiminished intensity. This is what is action potential. So it is nothing but it is a sequential change in the membrane potential. Why is there a change in membrane potential? Because of the opening and closing of the ion channels. What are the ion channels? We will see sometimes later. And how is this membrane potential propagating? It is propagating along the excitable tissue in undiminished way. That is, the action potential does not fade. And what is this excitable tissue? This excitable tissue is nothing but it is either your nerve tissue, that is your neuron, or the muscle tissue. So this is what is the action potential. Now let's see the graph. See that minus 70 millivolt. What is it? It is the resting membrane potential. There is no action potential at that particular moment. Our y-axis is representing the membrane potential in millivolts and the x-axis is representing our time in milliseconds. Now, when we have increased the membrane potential up to minus 55 millivolt, then see there is a sudden increase in the membrane potential. Sudden rise in the membrane potential. This is called the phase of depolarization. After reaching plus 35 millivolt, there is again lowering of the membrane potential. This phase is called the repolarization. And after that, it is turning more and more negative. There is more lowering of the membrane potential, which is called the hyperpolarization. Now, what is causing this depolarization, repolarization and hyperpolarization? Let's see. When we apply a threshold stimulus, it is very important that action potential comes to play when we apply a particular stimulus, which is called the threshold stimulus. Until and unless you apply the threshold stimulus, there will be no action potential. So after the application of threshold stimulus, there is depolarization. What is depolarization? It is the sodium ion entry, that is the sodium ion influx due to the opening of the voltage gated sodium channels. Next, there is repolarization. It is due to the potassium ion efflux. After that, there is hyperpolarization. This is due to the further potassium ion efflux. Now let's see, after hyperpolarization, what is this distribution of ions in the cell? There is more and more potassium ion outside the cell. That is, the extracellular concentration of potassium ion is more and the intracellular concentration of sodium ion is more, which is absolutely the reverse condition, because we know that in normal state the extracellular concentration of sodium ion is more and the intracellular concentration of potassium ion is more. So, to return to the original state, we are having this very important pump, which is our sodium potassium ATPase pump, and this is present in almost all of the cells of your body. What is this pump doing? This pump is restoring the original state by pumping out 3 sodium ions and pumping in 2 potassium ions in the expense of ATP. So this in turn is restoring the normal ion distribution in the cell. Now after all this, after having such a good idea of what action potential is, let's come back to the question. What is the question? The question is that which of the following graph correctly represents the recorded response by 2 electrodes of the stimulus of Y intensity, right? So let's see. So there are the 2 electrodes. Now let's see. Now just see one thing. We have learned that what is action potential? Action potential, it comes to play when we apply a threshold stimulus. Now after applying the stimulus of Y intensity, a response is recorded. So this is actually the threshold stimulus which is being asked in the question. And we have also learned that action potential propagates in an undiminished way. So in both the electrodes, the amplitude of this action potential should be same. In which of the graphs are we seeing so? It is obviously in our graph B. The amplitude of both the action potentials are same because action potential transmits in an undiminished way. One important thing, that if we apply a stimulus which is more than the threshold stimulus, is it going to increase the amplitude of the action potential? No. Why? Because action potential follows a very important principle, which is the all or none law. What is this all or none law? This all or none law states that applying any stimulus above the threshold stimulus is not going to alter the amplitude of the action potential. So no matter how much you increase the stimulus above the threshold stimulus, it is not going to change the amplitude of the action potential. Now let's come back to the question. In the next question it is asked that which graph correctly shows the response if the stimulus intensity is increased to 2I units. We know that action potential follows the all or none law. So no matter how much you increase the stimulus above the threshold stimulus, it is not going to change the amplitude of the action potential. Thus the amplitude will be same. Now we will see that amplitude is same in both the options, option A and option C. Which one should be correct? We will choose the option or choose the graph which is actually the graph of our previous question. Why? Because in our previous question the graph represented is according to the intensity Y, that is in accordance to your threshold stimulus. In our second question we are applying 2I units, but according to the all or none law this is not going to affect the amplitude. So in the second question also we will have the same graph as the first question. So our option would be option number C, which actually resembles the graph of our previous question. This is all about the question, which is a very simple question. Please don't skip any question just seeing its length, because many a times in the question paper these questions which appears lengthy seems to be the most doable and the easiest question in the entire paper. So judge the question, analyze it before leaving. This question was a very simple one, but this was given in a very complicated way. This is the question of your IOQB 2021-2022. I hope so. It is clear, and Team Inquipedia will be coming up with such interesting questions. Don't forget to like, subscribe and press the bell icon. Stay tuned. We are very glad that and to help you, we will help you unconditionally, and your small support, your small love would help us to grow, would motivate us very much. See you in the next video.